Now let us look at the next problem. Two spherical planets P and Q have same uniform density rho, masses MP and MQ, and the surface areas A and 4A respectively. A spherical planet R also has uniform density rho and its mass is MP plus MQ, that is the sum total of both the planets. The escape velocities from the planets VP, P, Q and R are given as VP, VQ and VR respectively. Then which among the four options are correct? Now we are given that their surface areas, they are in the ratio of 1:4 and surface area is given by 4 pi r square. Okay, so it basically means that if we compare the radius of P and Q, if the radius of P is r, then the radius of Q has to be 2r. Okay, is that clear? Now also their densities are same, so if we consider the mass MP as m, which is equal to 4 by 3 pi r cube times rho, density into volume, then the mass is m in case of P, then the mass of Q will be 8m because radius is 2r, so it is rho 4 by 3 pi 2r cube, which is 8 times this expression, which basically means that it is 8m. Okay, so if we make a comparative chart of P, Q and R, then density is same in all the three cases. The density, the mass is m, so here it is 8m, and since the mass of R is the sum total of P and Q, now this will be 9m. Okay, cross sectional surface area is A, this is 4A, and radius is R, and here it is 2r. Now we have to find out the radius of planet R. Now since the mass is 9m, total mass is 9m, which basically means that would be equal to density into its volume, 4 by 3 pi r cube, r cube. Okay, and we know that the value of m is 4 by 3 pi small r cube into density, which is equal to rho times 4 by 3 pi r cube. So 4 by 3 pi cancels out, rho cancels out, and we have radius of r equal to cube root of 9, which we can write it as 3 to the power 2 by 3 times r. Okay, so the radius is 3 to the power 2 by 3 times r. Okay, now we need to also find out the relationship between escape velocity and the radius. Escape velocity is given by under root of 2g m by radius r. Okay, now 2g m can be written as 4 by 3 pi r cube into density upon capital R. So this will now become squared, so now we can write it as escape velocity as under root of 8 by 3 g pi rho, and r square will come out of it, so r. That means escape velocity is directly proportional to the radius of the planet if rho be constant. Now if this is the case, escape velocity is directly proportional to the radius. So if we take the ratio of Vp is to Vq is to Vr, that will be equal to ratio of radius of P, radius of Q is to radius of R. Now we know that the radius are in the ratio of R is to 2R is to 3 to the power 2 by 3 R. Okay, so this RR will cancel out, so the ratio is 1 is to 2 is to 3 to the power 2 by 3. Okay, so this is the ratio. Now we will look at the options that are given. Now the ratio of V, Q and R is 1 is to 2 is to 9 cube root. Now this value is more than 8 cube root and this is 2. So the value of this 9 to the power 1 by 3 is definitely more than 1. So VR is more than VQ is more than VP. Okay, so option B is correct. Another thing is the ratio of VP by VQ is 1 by 2. So both option B and D is correct.